Hi folks, welcome back. I hope you're all doing well. So after ChatGPT, I think the real killer application for large language models that most people and most companies are really waiting for is to use large language models to answer questions over their own private corpus. You don't just want to talk about generic things with an LLM like you do with ChatGPT. You want to ask it very specific questions about your set of documents, your domain specific set of knowledge that you care about. And you want the large language model to be able to synthesize answers to your questions that are grounded in those documents and that are not hallucinated. The very high level way that people have largely converged on for how to do that is a design pattern called Retrieval Augmented Generation. And I've made a video about that on this channel before. I'll link to it down below. But the idea is to first retrieve documents that match your query or the prompt, and then use relevant snippets from those documents to add to the prompt and give that additional context to the LLM to synthesize the final answer. Today I want to look at not one but actually two papers that put a twist on that design pattern by incorporating the chain of thought prompting pattern with that kind of retrieval augmented generation. In this first paper, the authors call their pattern rethinking with retrieval. And the basic idea, as you can see in this diagram, is to use a chain of thought prompt and enhance it with documents that have been retrieved from your specific corpus. And just for background, the basic idea of chain of thought prompting is to elicit the reasoning or the steps of thinking that went into an answer rather than provide the answer itself. They use a running example in this paper. If you ask the LLM the question, did Aristotle use a laptop? Instead of asking for a yes/no answer, chain of thought prompting asks for the reasoning behind that answer. So a chain of thought prompt would ask the LLM to give an answer of the form Aristotle died in such and such year and the first laptop was invented in such and such year, and thus Aristotle did not use a laptop. So here's how rethinking with retrieval works. You ask the LLM to generate not one but a few reasoning paths, and each of those reasoning paths will have an explanation, the steps of thought, followed by a final answer or a prediction. Once you have those multiple chains of thought, you then retrieve relevant documents from your corpora. And to narrow down to one correct explanation, you select the prediction that is most supported by the retrieved documents or the underlying ground truth facts. So carrying along with the running example in this paper, if you asked, did Aristotle use a laptop, the very first step would be getting a number of different reasoning paths or chains of thought. For this particular example, you could get one that says Aristotle died in 2000 and the first laptop was invented before that, so the answer is yes. You get two others with different dates for Aristotle's death and the invention of the first laptop, and both of those say that the answer is no. So you have three different chains of thought. How do you choose between them? This is where the retrieval step comes in. They're using Wikipedia as their corpus, and what they pull up is Aristotle's date of birth and the year that he died, and the year that the first laptop was invented. And now that you have these two facts that you've pulled out from your corpus, you can look at which of the chains of thought are supported by those facts. So in this case, both the second and third chains are more supported by the facts that you pulled from your corpus, and so you pick the answer no. They tried out this strategy with three benchmarks, one which has some common sense questions and answers, another one that has questions and answers related to time, to temporal sequences of events, and a third one that has a lot of tabular data and then asks questions about the data in those tables, and they compared it to some of the standard methods without retrieval, like zero-shot or few-shot prompting, or even chain-of-thought prompting. And in the benchmarks, they do beat all the other methods. As you can see, this strategy of rethinking with retrieval gets the highest points in all the benchmarks. I think this is the fraction of the questions in the benchmark that were correctly answered. So that's pretty promising because you're getting pretty good results in terms of the factuality of the answers you're getting from the LLM without needing any additional training or fine-tuning. This is just based on documents retrieved from your corpus. Now let's look at another paper which also tries to mix chain of thought with retrieval augmented generation. And this one uses more of an interleaving strategy. So here also you start by giving the LLM a chain of thought prompt, but then you interleave retrieval and further prompts based on each of those steps. So the document affects the prompts and the prompts affect the further documents that are retrieved. So here's a simple example. You start by asking what country Lost Gravity was manufactured in. Apparently it's a roller coaster. The first thing you get when you look up your corpora is not the country, but the name of the manufacturer. And then you look up your corpora again, and it tells you that the manufacturer is a German company, which leads you to the final answer, which tells you what country it was manufactured in. The intuition behind this pattern is that without retrieval, without being grounded in your ground truth corpora, the model will probably hallucinate. But also, without having some reasoning steps, you won't know what to retrieve for the subsequent steps. And that's what leads the authors here to propose an interleaving approach. You use retrieval to guide the chain of thought steps. So right at the beginning, you retrieve some snippets from your corpora using the initial question as a query, and then you alternate between using that question and the retrieved paragraphs to generate the next chain of thought step and getting more retrieval information based on what the last chain of thought sentence was. And you keep doing this until your chain of thought ends by saying, and the answer is dash, or you bump into some maximum number of steps. So here's another example that demonstrates that you're asking who wrote the 1970 hit song that Murray Head is most recognized for. And the way you set up the prompt, you start by setting up a few-shot prompt that explains your chain of thought setup, and then you alternate between a reason step, which generates the next chain of thought sentence, or a retrieve step, which retrieves a few more paragraphs from your corpora based on the last chain of thought sentence. And you keep tagging that on to the prompt as you go along these steps. So the first step tells you what the title of the song is. The second step tells you who the authors of that song were, and that's the answer. So you alternate between reason steps and retrieval steps. And here are some benchmarks on a number of Q&A benchmarks, and they compare it with 1R. 1R is just a one-step retrieval augmented prompt where you just retrieve documents related to your query, put them into the prompt, and ask the LLM to generate an answer in one shot, as opposed to the interleaved strategy that the authors here are proposing. And this top set of graphs is recall, and the bottom set is answer F1, which is a blend of recall and precision. And you can see that the interleaved approach is doing better on both of these dimensions. So that was a quick look at a couple of enhancements to the common retrieval augmented generation pattern for LLMs synthesizing answers to questions over your own private corpora, both of which try to incorporate chain of thought prompting into the retrieval process. If you like content like this, please like the video, consider subscribing, and I will see you all next time. Thank you very much.